50 million years ago, Greenland tore itself apart from Europe, and this created the Atlantic Ocean between these two continental masses. There was a chain of volcanoes that was created at the time that led to the formation of the oceanic crust. And in East Greenland now, it's only the roots of these volcanoes that are exposed. One of our main questions, or one of the big reasons why we went to Skaergaard, was to gain an understanding of how magma chambers work. One thing that Skaergaard is world famous for is the layering in these rocks. So when you look at the rocks from Skaergaard, you see these zebra stripes or alternating bands of black and white minerals, and it's really sort of puzzled geologists and has been a point of interest for many years. So we went there to test some of the latest ideas about how these rocks crystallize and how these crystallization processes produce ore deposits. They start to crystallize at a high temperature of maybe 1000, 1100 degrees C. And by the time that they're fully solidified, that's at a temperature of 700, 850 degrees C. And it's this particular window in time when there is both solid and liquid coexisting in the system on the boundaries, the cooling boundaries of this intrusion. These are the processes that we're especially interested in. So when we're in the field, one of our main jobs is to collect observations from the rocks. And it's a bit like solving a detective puzzle or a murder mystery kind of thing. Nature's run this experiment and has preserved a whole bunch of clues in these rocks, and it's our job to go and interrogate the rocks and understand what thing has happened to it to produce what we see today. So we have some answers actually for what happens to the liquid magma in this part of the system. We can see that at a particular temperature, the liquid splits into two parts. It splits into one part that's extremely rich in iron and one part that's relatively depleted in iron. The iron liquid, in the case of our study area, contributed to the formation of a deposit or some layers, intervals in the rock that are rich in iron, titanium, vanadium, and maybe gallium. Our research questions have implications for the Greentech revolution. That is how society transitions to a low-carbon future. As society transitions to that low-carbon future, we're going to need resources to develop new technologies such as batteries, magnets for wind turbines, as examples. Some of the new battery technology depends on vanadium, and vanadium is one of the key metals that we were trying to understand, not origin of, but how it's concentrated in the ground to levels that are significant.